Yeah, what we really wanted to achieve here is like, well, why make this really fast car that's crazy fast and everything? We got to show that an electric car is the best car.
We have a very good relationship with Toyota, and they're a significant shareholder in Tesla.
Elon Musk's vision of an all-electric world seemed unstoppable. Until late 2024, something shifted after a secret meeting at Toyota's headquarters in Japan. Elon Musk emerged visibly shaken. What he saw that day would challenge everything we thought we knew about the future of transportation. Let's dive in. The rise of an empire. Elon Musk thought he had won. Tesla's stock was soaring. Legacy automakers were scrambling to catch up, and the future seemed purely electric. But while the world was fixated on the EV revolution, Toyota, the world's largest automaker, was quietly working on something that would change everything. This isn't just another hybrid system or a minor improvement. Elon himself has said that this new engine could destroy the entire EV industry. But before we get to that, let's rewind and understand how we got here. The story begins nearly a century ago. In a small textile company in Japan, a family's dedication to innovation laid the foundation for one of the greatest technological leaps in automotive history. Sakichi Toyoda, an ingenious inventor, revolutionized the textile industry with his automatic loom. This invention not only automated weaving but also introduced the concept of jidoka, automation with a human touch. Machines could halt automatically when a problem occurred, a principle that became a cornerstone of Toyota's manufacturing philosophy. Building on his father's legacy, Kiichiro Toyota ventured into the automotive industry. Observing the inefficiencies of American mass production, Kiichiro envisioned a more streamlined approach. He developed the just-in-time JIT production method, emphasizing producing only what was needed when it was needed and an exact amount required. This strategy minimized waste and optimized efficiency, laying the foundation for the Toyota Production System, TPS. The TPS is built on two pillars, JIT and jidoka. While JIT focuses on synchronizing production processes to reduce waste, jidoka emphasizes quality control by empowering workers and machines to detect and address issues immediately. This dual approach not only enhanced productivity but also ensured quality at every step. Toyota's commitment to continuous improvement, known as Kaizen, further set it apart. Every employee, from assembly line workers to executives, was encouraged to seek out and implement improvements in their daily tasks. This culture of perpetual innovation allowed Toyota to stay ahead of the curve. Toyota's foresight during the oil crisis. During the 1973 oil crisis, as fuel prices soared and consumers demanded more fuel-efficient vehicles, Toyota was ready. Models like the Corolla offered exceptional fuel economy, while many American manufacturers struggled with declining demand for their gas-guzzling vehicles. Toyota's agility during this period solidified its reputation as a forward-thinking automaker. In the early 2000s, Toyota once again demonstrated its innovative prowess with the introduction of the Prius, the world's first mass-produced hybrid vehicle. By combining a gasoline engine with an electric motor, the Prius delivered impressive fuel efficiency and reduced emissions, appealing to environmentally conscious consumers. This move set a new standard in automotive technology and underscored Toyota's role as a pioneer in sustainable mobility. The internal combustion legacy, the internal combustion engine, ICE, has been a cornerstone of technological advancement for over a century. Its evolution is marked by continuous improvements in efficiency, power, and reliability. Toyota's journey with ICEs is no exception. In the 1990s, Toyota introduced the legendary 2JZ engine, a 3.0L inline, six powerhouse found in models like the Supra. Known for its durability and performance, the 2JZ became a favorite among tuners and racers. Toyota didn't stop there. In 1995, they introduced variable valve timing with intelligence, VVTI, optimizing engine performance and fuel efficiency. Later innovations like dual VVTI and the Valvomatic system further refined engine responsiveness and reduced emissions. By 1997, Toyota revolutionized the automotive world again with the Prius, combining a gasoline engine with an electric motor to create the first mass-produced hybrid vehicle. This innovation set a new standard for environmentally conscious driving. Enter Elon Musk. In 2008, as Toyota was refining its hybrid technology, a new player emerged, Tesla Motors, led by Elon Musk. Tesla's mission was clear: electric vehicles were the future. Tesla's Roadster, launched in 2008, shattered preconceptions about EVs, proving they could be high-performing and desirable. The Model S, introduced in 2012, further cemented Tesla's reputation, becoming the first electric car to top monthly sales rankings in any country. Tesla's rapid ascent wasn't without challenges. Production delays, financial pressures, and regulatory scrutiny tested the company. Yet, Tesla's influence extended beyond its vehicles, spurring traditional automakers to accelerate their own EV programs. The battery dilemma. As the automotive industry accelerates toward an electric future, the enthusiasm for EVs is tempered by significant challenges in battery production. Lithium-ion batteries, the cornerstone of most EVs, rely on critical minerals like lithium, cobalt, and nickel. Mining these materials is resource-intensive and often environmentally damaging. For example, lithium extraction in South America has led to water depletion in arid regions, while cobalt mining in the Democratic Republic of Congo has been linked to human rights abuses. The battery manufacturing process itself is energy-intensive, contributing to substantial greenhouse gas emissions. Additionally, the global supply chain for these materials is fraught with geopolitical tensions, raising concerns about resource scarcity and price volatility. End-of-life battery management is another issue. Currently, only about 5% of lithium-ion batteries are recycled, with improper disposal posing environmental risks. While companies like Nissan and Volkswagen are investing in recycling initiatives, widespread implementation remains limited. Toyota's revolutionary engine technology in 2024, Toyota, in collaboration with Subaru and Mazda, announced the development of advanced internal combustion engines designed to integrate seamlessly with hybrid systems and operate on carbon-neutral fuels. These engines are more compact, efficient, and versatile, capable of running on gasoline, synthetic fuels, biodiesel, and even hydrogen. One of the most groundbreaking aspects of Toyota's new engine technology is its capability to utilize hydrogen as a fuel source. Unlike traditional fuel cell vehicles that convert hydrogen into electricity, Toyota's approach involves the direct combustion of hydrogen within the engine, producing zero carbon emissions.